Well, this is your friendly neighborhood physics teacher to help you about torque. Now, if you remember from class, torque is basically the force that causes rotation, that causes something to turn. Something to turn. That is what torque is. It's the force that causes something to turn. Now, the equation for torque, you have this funny little curvy little t. It's called tau. It's a Greek letter. And it equals your force times your distance. So force times your distance. Now, your distance is a little bit special because it's the distance from the pivot point. From the pivot point. It's a distance from the pivot point. So let's think about a door real quick. No, I don't want to click on that. So you have a door. If you put a force at the end of the door to open it, like normal, the distance that you would use would be the whole entire door. Now, if you're putting a force like in the middle of the door, the distance you would do is from wherever you put, like it would be from the middle of the door. So it's wherever your force, you're placing that force, and it's from your pivot point. So that would make your hinges your pivot point, or your fulcrum. Now, a lot of the examples we did in class was like of a seesaw aspect of it. You had, a little thing to support, you had a beam, and you might have had a kid over here, might have had a kid over here, and you would have to find like the distance or find the force of said object. So again, we have, and I gave you kind of little steps. So step 1 was to find your pivot point. We found our pivot point. Kind of like in this area right there. That's a pivot. Next thing, while finding the pivot point, you have to find your distance. So that's your distance. We'll call him 1. That's your distance for 1. And your distance for 2. We'll call him 2. And again, it's your distance from your pivot point. And then you either have to be given or find your force. Now, if you think about what type of force is causing the bar to rotate. So in this case, it's force of gravity. So to be specifically on what type of force. So this is force of gravity of kid 1. This is force of gravity of kid 2. And that's kind of your setup there. And you go and you do your torque of 1 is got to equal your torque of 2. Why do they have to equal? Yeah, because they're balanced. It's just like your net force. Your torque is the exact same way. If it's not moving, your torque is balanced because it's not rotating. On the notes, another way you saw it is maybe looking at it like you saw torque of C equals torque of AC. That's just talking about clockwise and counterclockwise. You have to think about how the object is rotating. This force here is making the seesaw go that way. It's pulling it down. If you look at the face of the clock, that's clockwise. This force here is making it rotate this way, and that's counterclockwise, or in my notes, it's anti-clockwise. And so instead of putting 1 and 2, if you wanted to put, clockwise and anti-clockwise, you could. Or I know that confused a couple of people. You don't have to put that, and you could just label it like I did and use 1 and 2. It's up to you. It's just a label to distinguish one side from the other. That's all it is. And so we go into our equation. You have force of gravity of 1 times your distance of 1 equals your force of gravity of kid 2 times your distance of 2. And like I said, you either have 1, so you either have your force of gravity of kid 1, or you just solve for 1. So let's say we needed the distance. You would just divide and get the distance by itself. So once you set it up, you're just dividing by something. It's according to what you're dividing by. And you'd end up getting your force of gravity of 1 times your distance divided by your force of gravity of 2 would give you your distance 2. Or you could have solved for force of gravity of 2 and you just divided by your distance 2. Or you could have solved any force of gravity 1 or your distance 1. Once you get what's making it rotate one side and what's making it rotate the other, you have this set up. So your main equation, is you look at your two torques, you set them equal to each other, which one's making it go clockwise, which one's causing it to go counterclockwise or anti-clockwise, and then set it up. What force is causing, and then the distance. And then your distance equals the force times your distance. So that is your biggest setup. And on your test, you do get torque equals force times distance. You get that. You just have to know that the two torques, as long as it's not moving, and none of your practice problems were moving, none of the test questions will be moving. So it will be balanced. You just have to figure out what balances what. So in the case above, you had 1 on one side of the pivot, 1 on the other side of the pivot. Let's say we go to something like the door. So you have kind of like a bar. Like, again, let's just think about we had something like the door. So, the first thing you're supposed to do is just, where's your pivot? There's my pivot. Yay. And then, you're supposed to describe your force. So you have some type of force, pushing there. And don't forget, in this case, we have to take the force of gravity of the bar, so of the door, I guess, in this case, if it's not, okay, I don't know, let's say it's a shelf, or gravity of the shelf into consideration. Okay, so if it's a shelf, here, we'll even draw something on the shelf. What's going to be on our shelf? Let's have, I don't know what's going to be on the shelf. Yeah, I don't know. A little teddy bear that looks horrible and scary. That's on our shelf. So then you have the force of gravity of the bear. And you would have to find the distance between those two objects. So this would be your distance of the shelf, and this would be the distance of the bear. Now you have to think about which direction is it making it rotate. Well, the bear is making it rotate that way, which would be anti-clockwise. And the shelf is also making it rotate that way, which is anti-clockwise. So they're both going anti-clockwise. So they're both going anti-clockwise. We're going to extend out said shelf. And we're going to put something over here. We'll put a picture. Some type of picture. And now you have a force of gravity of your picture, which is causing it to rotate clockwise. So you have two that are going anti-clockwise. You have one that's going clockwise. Again, it's the same thing. You balance it out. So it's your torques going clockwise equals your torques going anti-clockwise. In this case, you only have one. I'm writing my distance of the picture. So you only have one going clockwise. So it'd be the force of gravity of your picture times the distance of your picture equals, but you have two going anti-clockwise. And so you have force of gravity of the bear times your distance of the bear. In this case, since they're going the same direction, you just add it. Force of gravity of the shelf times the distance of the shelf. So if you have two turning the same way, you just add them together. It's supposed to be a D. And that's kind of your setup there. And again, you would be missing one thing, and you solve that. Now it just becomes algebra to solve what you're missing for. The biggest takeaway from this problem is if you have a bar, the force of gravity happens at the center of mass. The force of gravity happens at the center of mass. That's where you place the force of gravity. Place force of gravity at center of, like, the beam. That's a D. Beam. So, that's the key thing. Make sure you put your force of gravity at the center of the beam. Now, like on your test, we might give you the mass, and you have to figure out the force of gravity. Now, this formula will be given on your test, but you take your mass times the acceleration of gravity, and we're on Earth, so our acceleration of gravity is just 9.8 meters per second squared. So you would have to take the mass, then multiply by 9.8, and then you would get your force of gravity. And then you would just plug it into any formula you have above. And that's pretty much torque in a nutshell. It's just the force that causes an object to rotate. You can think about is it rotating clockwise or counterclockwise. You want it, all your practice problems and all of this will be balanced, so you have to do side of one, it's got to equal side of the other, and then it just becomes algebra to solve. So let's do a practice problem. So you have and I kind of did this in class during tutoring. You have a meter stick. You have a meter stick, and I was trying to balance. Actually, at that point, it was the soap bottle. Was it in the soap bottle? Yeah. Like on the lab tables, there's the soap bottles. Yeah, it was the soap bottle, and then I was balancing the Expo marker eraser. So I had the soap bottle and I had the Expo marker eraser. And I actually balanced it. I got it to balance. Woohoo! Let's make that into a problem, a practice problem. So, let's say the mass of the soap bottle was like 2.5 kilograms. Let's say the mass of the eraser was 0.5 kilograms. And so the first thing, you have to figure out your pivot point. So there's our pivot point. Point. So that's our pivot. And then we know we have the force of gravity of the soap. We know the force of gravity of the eraser. Now there's one other thing we need to know. Since it's off center, we need to know the force of gravity of the meter stick itself. The force of gravity of the meter stick and stuff. And remember, that's going to happen at the middle point. What's the middle of a meter stick? 50 centimeters. Very good. Let's say the pivot point here is at 10 centimeters. Okay. You have to figure out how far away the eraser is. And the mass of, I didn't give you all the mass of the stick. Sorry, guys. The mass of the meter stick, let's just say it's 1 kilogram. So first we have to figure out the force of gravities of each of our objects. So the force of gravity of our soap would be 2.5 times 9.8. So 2.5 times 9.8 gives you 24.5. Then you'd find the force of gravity of your meter stick. So that's just 1 times 9.8. So the force of gravity of the meter stick is just 9.8. And then you need to figure out your force of gravity of your eraser, which is the mass of the eraser is 0.5, which times 9.8. So 0.5 times 9.8 gives you 4.9. So we figured out all our forces of gravity. Now we need to figure out our distance. So if this is at 10 centimeters, we know that the distance here, distance of the soap, would be 10. So the distance of our soap would be 10 centimeters. The distance here, you just subtract 50 minus 10, give you 40 centimeters. I'm giving you all the information, aren't I? That's what happens when you come up with a question off the top of your head. And so the distance of the eraser should be 90 centimeters. So you know what we're going to do? Achoo. We're looking for our force of gravity. Remember, I just made up these numbers. So I gave y'all too much information. Things wouldn't have balanced. It would start to rotate, what I did. Sorry about that. So now, again, we have to decide which direction is it rotating, clockwise or counterclockwise. So our eraser is making it go clockwise. Our force of gravity is making it go clockwise. Our soap is making it go anti-clockwise. So you have one on one side, one on the other. You have torque clockwise, it's got to equal torque anti-clockwise. So we have two that are going clockwise. You have the force of gravity of the meter stick times the distance of the meter stick plus the force of gravity of the eraser times the distance of the eraser. And that all has to equal the force of gravity of the soap times the distance of the soap. You just plug in what you got. So we don't know the force of gravity of the meter stick, so that just stays. Our distance was 40. Force of gravity of the eraser was 4.9. Our distance was 90. Our force of gravity was of the soap was 24.5, and our distance was 10. Now, you notice I kept my distance in centimeters. I didn't convert to meters. You can do that as long as you're not looking for the distance. If you're looking for the distance, you have to convert. And you just, so you multiply 4.9 times 90, and you get 44.1. That equals, you do 24.5 times 10, and that just moves it over 1, so that gets you the 245. And then don't forget what we're looking for over here, your force of gravity of the meter stick, and we do still have the distance. So we're trying to get the force of gravity of the meter stick by itself. So what do we have to do? Yes, we have to subtract this over here. So that'll give us our force of gravity meter stick times 40 equals, and you'll have that minus 441, and that will give you a negative number. Got your negative 160. All that again, so remember, negative in physics just means direction. That's all negative means in physics. It just means direction. And so then you divide by your 40, and you get that your force of gravity with a meter stick equals equals 4.9 newtons. Now, that's in newtons. Let's say that it was asking for your mass instead of your force of gravity, so pay attention to your problem. If it's asking for the mass, remember your force of gravity equals mass times your acceleration due to gravity. So you just plug in 4.9 equals, you're looking for your mass, acceleration on Earth is just 9.8. So you just divide by 9.8. So you get 4.9 divided by 9.8, and your mass is 0.5. So if I left my 1 kilogram like I originally had it, the thing would have toppled over. It wouldn't have been balanced. But since now the mass is 1.5 kilograms, it balanced out. Now, you notice I did drop the negative. Remember, I just said the negative is direction. So all that's telling me is that force is making it rotate in the it's just saying that the force of gravity is down. That's all it's telling me. And it is. Force of gravity is always down. So, again, negative is just a direction. We're just looking for mass. Mass doesn't have a direction, so you can just drop the negative. That's about it for torque. You'll be given your equation. So, quick overview. You'll be given your equation. Torque equals your force times distance. Don't forget, if you're given the mass of the object and it's sitting on something, most likely your force is your force of gravity. So you have to do mass times acceleration due to gravity. If you have a meter stick or a long beam of some sort, remember that the force of gravity comes at the center of mass, and that's the force of gravity of the said stick, beam, meter stick, and that you set one side equal to the other. That's about it about torque. I know we did a few angles in class. Those questions got cut out of the test, at least the torque angles. So it's just very straightforward with torque. If you have any questions, please email me. I hope you have fun studying. Bye.